Hello there. Welcome to this presentation, deploying Kubernetes stateful workloads in AWS in 3 simple steps. For the first step, we're going to start in the AWS EKS console. And what we're going to do is create an EKS cluster. I'm just going to call this StorageOS. And for this, I'm just going to accept the defaults. Here we're selecting the cluster service role, which in my case is EKS service role. I'm just accepting the defaults for the networking and security groups. And then if we scroll down to the bottom, then click next. And we accept the defaults for login. And lastly, we're on the review and create. And I'm just going to click create there. So with that, our cluster is creating. This takes approximately 7 to 10 minutes. So at this point, have a little bit of a break. And then if you refresh, you should see the cluster created as follows. With our cluster created, we can now add worker nodes. If we click compute, and from there we click add node group. And for this, I'm going to give it the name of StorageOS-nodes. Then we select an IAM role. And then right at the bottom, click next. And for this, I'm going to deploy 3 nodes. And then right at the bottom, next again, accepting the subnets that we've already got there. And finally, choosing create. And if we click back on nodes, at the moment that's not showing there. If we just refresh, and there we have our available nodes. And at this point, we can actually configure our kubeconfig to access the running Kubernetes cluster. If we go to our terminal, what we're going to do is use the AWS CLI to configure our kubeconfig for access to the cluster. If we execute a kubectl get nodes, you can see there that we've got 3 EKS nodes ready and available for consumption. So that's part 1 covered. In this next part, part 2, what we're going to actually do is look at setting up and configuring StorageOS for persistent stateful workloads. So firstly, we're going to start with the installation of etcd. StorageOS uses etcd in much the same way that Kubernetes uses etcd, and we actually use it for storing configuration information and for various locks and ownership. And you can actually see there at the bottom, we have the endpoint for etcd access. So as we go through this, we'll be making reference to that address at the bottom there. We're going to install the StorageOS operator. Next, we're going to set up the credentials that are going to be used for StorageOS. In this case, this is a standard Kubernetes secret. Just to actually show this, if I take that value and we pass that through base64 and decode it, you can see there that we're using the value of StorageOS for the username and password in this setup. Next, we're going to set up a StorageOS cluster. This uses the custom resource of StorageOS cluster, which we actually installed using the operator. And it's pretty straightforward. We've got an actual reference there to the version of StorageOS that we're installing. On the KV backend, you can see the reference to etcd, which is what I actually showed there in that first step. And in terms of resources, we have requests for 512 megabytes and 1 CPU core. So you can actually run this with an extremely light footprint. This script that I've got here is just a convenient wait script, and all it actually does is make sure that all of the components are running as expected. So we can see that That is completed successfully. Next, we're creating the storage class, and for this one, we're actually calling it top secret. With Kubernetes, a storage class is a good gateway, especially when working with StorageOS, to have different features and functionality tied to a storage class name. So in this example, we're using the name of top secret, replicas too. So this actually means that we have one primary source of data plus 2 replicas, and then we have encryption set to true. And if we take a look there, we've got the default storage class of fast. So when you actually install StorageOS, it sets up a default storage class. We have GP2, which is one which is actually provided by EKS. And then we have the top secret that we have just created. Okay, so that covers us for part 2. And for part 3, what we're going to actually do here is configure a stateful application using StorageOS and Kubernetes. So with that in place, what we're going to do now is create a MySQL persistent volume claim and the corresponding persistent volume. You'll notice in this example that all we've actually done is the persistent volume claim. And with StorageOS installed, you don't actually have to do the persistent volume. It is actually part of the persistent volume claim process. If we take a look, you can actually see there that we have the persistent volume and the persistent volume claim. And as I mentioned, this is an encrypted volume because we actually have the encryption option as true in the storage class. So if we actually take a look, we're doing a kubectl describe on the persistent volume claim, and within the annotation section, you can see that there's a reference made to the secret name. So what we've actually got there is a secret that is used to actually hold the encryption keys for encryption at rest. What we're going to do now is taint the other nodes so that we force our workload to the first available node in our cluster. So the first node that is actually schedulable. We've just created a MySQL pod, and within this, it's quite a simple declaration. At the bottom, we have the volume mounts and the volumes. You can actually see that MySQL is running there, and we have our persistent volume and our persistent volume claim in the output at the bottom. What I'm going to do, I'm just going to check the logs for MySQL, and that's what I was looking for there, right at the bottom. MySQL D, ready for connections, and we have the socket listed. Okay, so now I've just populated the running MySQL instance with some data. You can actually see there that I've passed it in some SQL. So now we're going to delete that pod. And what we're doing here is adjusting our taint. So previously this was actually forced to run on the first node. We're now actually tainting that node so that it can't run there. We're untainting the second node. So next time the Kubernetes scheduler runs, that will be the only node that it can actually schedule to. We recreate the MySQL pod. So again, this is using exactly the same example as we actually saw there from before. And we can see that MySQL is running there. And again, I'm just going to check the logs. Yep, that's good, ready for connections. And now if we check the MySQL data, you can see that we've got access to all of our data. So even though the instance is actually, it's been terminated and now it's actually been deployed to a different node in the cluster, we can actually use persistent data as you would actually expect in Kubernetes.